Well, grade 10s, in this lesson, we're going to go further with graphs and we're going to be looking at what we call linear functions. Now, linear functions are really straight lines. You probably remember them from grade 9 days, but I'm going to link it to what we did in a previous lesson. Okay, and the important thing with a linear graph, it takes on the form y equals sort of mx plus c, some books use. In the new syllabus, they talk about y equals ax plus q. If you remember that in last year we spoke about gradients, your teachers probably spoke about that, and then c was the y-intercept. But don't panic with this. We'll talk about that as we go along. We'll revise this again. The straight line could either go to the right or to the left like that. And there was a whole lot of mathematics in that on the linear function or straight line graph. Okay, so we're gonna explore this, but what I want to do, I think more importantly, is let's take an example. Say, for example, y is equal to x minus 2. Now, I don't want you to get caught up with all this at the moment, okay? Don't worry. In fact, let's delete that because otherwise you're going to get a little bit confused. But it's something that we will come back to, and in what we're doing there. So let's clear that, and let's start by looking at the graph. I pretend that you've never seen what this graph looks like, okay? But link up to my previous lesson. What we did, remember in the previous lesson, we select some values for x. So let's suppose I make up some and I say, okay, let's make x negative 1, say 0, 1, and let's go up to 2. And we want to work out the corresponding y values. Now think about this. What we're going to do to these x's that we've chose independently, I'm going to subtract 2 from them. So if you look at this, if I take x is equal to negative 1 here, okay, I'm going to do something to the y. The y is going to take that x and subtract 2. So I'm going to subtract 2 from all of these x's here. I'm subtracting 2. Okay, what's negative 1 minus 2? Negative 3. You can see there. Okay, and if x is naught, what would my y be? Well, it says take the naught and subtract 2, which gives you negative 2. What is 1 minus negative 2? Negative 1. Again, if you have a look at that, if we do it, you can write it here. There's x is equal to 1 and x is equal to 2. So your y would become, the x value is going to be 1 subtract 2, which is negative 1 there, and the y value is the 2 subtract 2, which of course is naught. So all it is, the x's you choose, you now subtract 2 from all of them and you get the y values. And of course it's wonderful, we can now represent these points. Remember, you've got negative 1, negative 3 as a set, so that's an x and a y, and we can represent. So let's go to a little graph here. Here's my grid, and what we can do, if we move that across, I'm just going to move my little grid across for you to see better. There we go, and bring it up a little bit. So let's move it across and up, and let's plot those points. Okay, here we go. Good. Cool. If you take the point, let's put some little markings on here. We go negative 1, negative 2, negative 3, minus 1, minus 2, minus 3. There we go. 1, 2, and 3, and 1, 2, and 3. Okay, here we go. So this is going to be negative 1, negative 3. So x is going to be negative 1, negative 3, and we put a little dot there. That is negative 1, negative 3. Then we've got the other point, which would be 0, negative 2. So let's draw that quickly. X is 0, negative 2. There we go. Let me put him over here. And then I think it's 1, negative 1. Let's just check that. 1, negative 1. Have a look here. 1, negative 1. Correct. And x is 2, y is 0. So then x is 2 and y is 0. There we go. Okay. Now remember from the last lesson, if you keep drawing these, if you keep drawing those, what do you get? I'm just going to make that little 0 a little bit clearer there because I'm going to use that in a moment. 2 and 0. If you now keep picking x values and subtracting 2 from them, you're eventually going to get what we call a whole lot of dots, and it forms what we call a graph or a straight line. Okay, and all of these dots lie on a line. And notice also that negative 2 tells me this is going to be called the, if you remember from grade 9, that's the y-intercept. And and this here is the x-intercept. And what I want you to notice something, because there's another method that you could also use. It's called the dual intercept method, which I think is quite fun. But I want to, before I do it, I just want to show you something quickly regarding this this dual intercept method. I want you to have a look here. Do you notice that for the x-intercept, the y is always naught? In fact, anywhere on the x-axis, the y would always be naught. If you look at that, that's negative 3 naught there. Do you see? And at the x-intercept, the y is naught. And also, if you look at the vertical axis, at this y-intercept, the x is always naught. Anywhere along the y-axis, the x is naught. So for the y-intercept, the x will be naught. Now this leads to another method. It's still like the table, but you focus on the intercepts. Now watch this. So for dual intercept, if you want your x-intercept, you're going to let the y be naught, because that will take you straight to your x-intercept there if your y is naught. And what about your y-intercept? Have a look at this. You're going to let the x be equal to naught. So if you take your equation, let's have a look at this, that they gave you for this relation, they call it, as you remember. If you let the y be naught, have a look here. Then all you do is you solve for x. So bring that across, so x is equal to 2. Look at that, which it is. X is 2, y is naught. That is definitely your x-intercept there. Okay, y-intercept, you're going to let the x be naught, and look at this. Y equals negative 2. So if x is naught, y is negative 2. What a pleasure. And that gives you your y-intercept. Also notice that the number here, this number at the end here, if it's in y equals something x minus 2, that number is the y-intercept. It's because x went to naught. Now, of course, we can easily draw those. If you have a look at your little graph here, if you have a look at this, if your x-intercept is 2, so it's there, 2 and naught, and the y-intercept was naught, negative 2. Look at that. And there we go. So once you've got those 2 points, you just simply draw the line, and you've got your graph, y equals x minus 2. What a pleasure. You can see that it's a wonderful method. Just be very careful too. Sometimes if you look at this, if I take, for example, if I look at this here, if I said to you, draw the graph of y minus 2x is naught. Okay, well, if you look at this, we could go y equals 2x plus naught if you bring it across. The problem here, the y-intercept is naught. Okay, now if the y-intercept is naught, the x-intercept is naught. If we try the dual intercept method here, watch this. You're going to see something interesting happening. For x-intercept, we're going to let the y be equal to naught, and the y-intercept, we let x be naught. So if you look at your equation here in both cases, for this one, x-intercept, you let y be naught, which of course gives you 2 times naught is naught. So your y-intercept is naught. But look at this. If the x-intercept, if you let x be naught, or y be naught, divide both sides by 2, x is naught. So you have a naught naught for both. Problem. So what we have to do is use a little table. So what I would do is I would suggest some values here. If you have a look here, you can say, well, if I pick some values for x, say minus 1, naught, and 1, what would my y values be? Well, if you're going to double these, so 2 times negative 1 is negative 2, naught, and 2, then we can plot it. There's our naught naught, x is 1, and y is 2. That gives us a bit of structure. Otherwise, we wouldn't know where the line goes. And then x is negative 1, negative 2 is there. Alright, negative 1, negative 2, naught, naught. And you then simply draw the line in like that. And there we go. And you've got your line. Okay, so if the y-intercept is naught, and it's always determined, so if you have anything 2x plus naught, if that's naught, then you know straight away. Now, in the practice example, something else is very interesting, and I want you to try this on your own using the dual intercept method. Let's see how it goes. Try this one, and I want to talk about that as well. Right, have a look here. The practice is sketch the graph of this thing quickly. See how it goes. 5x plus 2y is going to equal 10. Have a bash, and I want to talk about this one. Okay, here we go, guys. If you look at the x-intercept, I'm going to let y be equal to naught. Okay, so I'm going to let my y be equal to naught. So you simply say, well, that's naught, so it's 5x is equal to 10. Divide both sides by 5. So your x-intercept is 2 and naught. Okay. Your y-intercept, we let x be equal to naught. So y-intercept, you let x be equal to naught. So you've got your 5 times x plus 2y is 10. That's naught. So 2y is 10 and y is equal to 5. Okay, here we go. So what is the y-intercept? Naught and 5. Okay, there we go. And what a pleasure. Now, of course, it's very easy to draw the graph if we just simply draw some axes quickly here. And you could do it as well. Sometimes in exams they actually give you the grid, but let's just do that quickly there, and here we go. Okay, there's your y-axis and your x-axis, and off we go. So let's just see, what was your x-intercept is 2, naught, so it goes there, 2, naught there. Great, 2 and naught. Always indicate those coordinates, and then we've got naught and 5, so it's naught, 1, 2, 3, 4, 5. There we go, naught and 5, and you simply then join those points. The y-intercept is 5, and there we go. Interesting. By the way, you might be wondering too, remember, this is the graph of 5x plus 2y is equal to 10. But you might say, but that 10 is not my y-intercept. How did you get that? Or how does it correspond? Well, what you could do is you could actually go, if you look at this, you could say, if you want to, you could basically solve for y. So you could bring that across. You could say 2y is going to be negative 5x plus 10. You could possibly divide both sides by 2, so you get negative 5 over 2x. Now watch this, plus the 5. Y equals mx plus c, and that is your y-intercept. And this we'll use a lot in the next lessons to come. So stay with us on Cell School. We're going to do some more. I'm going to show you the gradient intercept method, which is really a wonderful method of drawing lines rather than the table method. So stick with us. It's going to be good fun in the next lesson.